Okay, we're going to start to take a look at how trig ratios are related to coordinates on the Cartesian plane. And we do this using a circle centered at the origin, so that's the center there, with a radius of 1. Okay, and we call this the unit circle. So when we measure angles using coordinates, they're always measured from the positive x-axis, so that's this line here, and anti-clockwise. So anything from here to here, like to the y-axis, would be an acute angle. And we call this the first quadrant. Okay, this one over here is the second quadrant, and that includes angles from 90 to 180 degrees. Down here is the third quadrant. So now we have angles from 180 to 270 degrees. And then we've got the fourth quadrant here, which has got angles between 270 and 360. Okay, so it's the opposite direction from when we were measuring bearings, so you need to keep that in mind. And we start from the x-axis. Okay, so the way that we can relate this to trigonometry is if we take any point on this circle, we know that the distance from the origin to that point is going to be 1 because the radius is 1. Okay, if I drop down a line perpendicular to the x-axis, you can see we make a right angle triangle. And the distance from the origin to here is going to be whatever the value of x is. And then the height of that triangle is going to be whatever the value of y is. So using my trig ratios, so if I start with the sine of theta, so there's theta there. So the sine of that angle is equal to the opposite, y, over the hypotenuse. So y over 1, which is just y. So we get that the sine of theta is equal to y. Same thing with cos of theta. That's the adjacent, which is x, over 1. So there it is, the adjacent over 1, giving us that the cos of theta is equal to x. And then the tan of theta is the opposite, which is y, over the adjacent, which is x, which we can't simplify. So tan of theta is equal to y over x. But that actually gives us a trig identity, so a relationship between tan, cos, and sine, because y, remember, is just sine of theta, and x is the cos of theta. Okay, so we get that the tan of theta is equal to sine theta over cos theta. Now, if I'm only dealing with angles between 0 and 90 degrees, so angles in this quadrant here, the value of x and y in this quadrant, so any point that I picked on this line, the value of x and y will always be positive. So that means that the value of sine, cos, and tan will also always be positive. And you can check that in your calculator if you take any angle between 0 and 90, like if you took an angle, say 75 degrees, and you took the sine of 75, the cos of 75, and the tan of 75, you'd see that you'd always get a positive value for that angle. Now, if we move into the second quadrant, so remember that was our first quadrant, that's our second one here, then what we see is that now these are our obtuse angles, so angles between 90 and 180. But now any point over here is going to have a negative x value and a positive y value. So that's going to affect whether or not sine, cos, and tan are negative and positive as well. Okay, now because we know that the sine of theta is equal to y, so because the sine of theta is equal to y and y is positive in this quadrant, that means the sine of any obtuse angle is also going to be positive, okay? And there's a relationship between, so say I had this angle here, and I said that was theta, then this angle here, that exact same one, would also be theta. But the angle that I want, the obtuse angle from the x-axis all the way over, is going to be 180 degrees minus theta. Okay, so what we can say then is that the sine of 180 degrees minus theta is just equal to the sine of theta. They have the same value. Okay, so supplementary angles, angles that add to 180 degrees, for sine have the same value. With cosine, because cos of theta is equal to x, and x is now negative in this quadrant, what happens is that the supplementary angle, so cos of 180 degrees minus theta, so that's my obtuse angle, is going to be equal to the negative of cos theta. Okay, so in the second quadrant, cos of theta is always a negative. The value of cos is always negative. Tan is the same thing. Remember, tan is equal to the y over x. Okay, and now because x is negative in this quadrant, we get that the tan of an obtuse angle is equal to the negative tan of the supplementary acute angle. So it's a little bit abstract to talk about it with just theta. We're going to look at some actual numbers now, and hopefully that will give you a better idea. If we want to relate the trig ratio of each basic acute angle to an obtuse angle, so that's 180 degrees minus whatever theta is, we would take a look here. So sine of 50 is going to be equal to the sine of 180 degrees minus 50, and that means that that's equal to sine of 130 degrees. And both acute and obtuse sine angles are always going to give you a positive value. Okay, but with cosine, remember we saw that it was different, that actually the cos of 38 degrees is going to be equal to the negative cos of 180 minus 38 degrees. Okay, so that's going to equal negative cos of 142 degrees. Okay, so if you want to see something a bit more concrete, you can enter cos of 38 in your calculator, and then you can enter the cos of 142 degrees in your calculator, and you'll see that the values are the same, but one's negative and one's positive. Tan is the same as cosine. It's also going to give you a negative value. So 180 degrees minus 81 this time gives us that tan of 81 degrees is equal to the negative tan of 109 degrees. So I'm actually going to stop there for now and say that actually you should probably do a section of the chapter in 2 parts. So I'm going to make it part 2 of this video. So for now, for exercise 4F, you should go up to question 8. Question 7, okay? And then come back and watch part 2 of the video. Otherwise, I think it's going to be too long and too much information all at once.